All right. Well, you need to be able to identify zeros, those are the x-intercepts, and be able to sketch graphs of polynomials. How to determine the lowest degree of a function from a graph. Well, let me type this out. Draw the horizontal line through the graph, which crosses it the most number of times. I'll give you a hint. It's not always the x-axis. The reason I say that is because some of you think it's always the x-axis, and I'm like, no. Sometimes it is, sometimes it isn't. So finding the number of real zeros from a graph. Okay, determine the lowest possible degree of a function. Well, in this particular case, the very first one that we've got, the x-axis works fine. So does that line right there. So the minimum degree is a third degree. Now, why do I say that? Well, imaginary solutions which don't show up on the x-axis you could have more of those, which would increase the degree of the function. Well, the next one, the x-axis is not the one. You want something above that so you can see that it is a minimum degree of 4. See what else we got here. For each graph, state the lowest possible degree. State the zeros. Write an equation of the polynomial in factored form with the lowest possible degree. Lots of things going on here. Well, the x-axis does work out this time, right? 1, 2, 3, 4. So lowest possible degree would be 4. Leading coefficient, well, that has everything to do with the right-hand behavior. And since the right-hand behavior is positive, going up, then my answer is positive. Maybe I should put a plus sign instead of POS because you guys think that means something else. Now, zeros, well, looks like it crosses at -4, -1, 3, and 6. All of those cut through the axis, so there are no bounces. So we've got x plus 4, x plus 1, x minus 3, x minus 6. And since that leading coefficient is positive, that agrees. We can leave it alone. Now remember on the next one, you cross your horizontal line through it, so the lowest possible degree is 4. The leading coefficient here is a negative because the right-hand behavior goes down. Zeros, well, we got -3, +1, but that's a bounce. So that's got a multiplicity of 2 because it's got to have an even multiplicity. and then positive 5. Now, another way to write that, which you may see at different times, another way to write that is this: negative 3, 1, comma, 1, comma, 5. So in other words, they're showing me the multiplicity of 2 for the x-intercept of 1. So we have x plus 3, that goes with your negative 3. We have x minus 1, that goes with your positive 1, squared. There's your multiplicity. Higher multiplicity than just a 1. And then x minus 5. Now the only thing wrong with this is that the leading coefficient is not negative. So, we'll just put a negative 1 out in front, basically. That'll take care of that. Now, if some kid put a negative 2, I literally probably couldn't argue with that. As long as it was a negative number. All right, let's see what the next slide brings. So it looks like we got 1, 2, 3, 4, 5. So that's the lowest degree is a 5. Leading coefficient, definitely negative. Zeros, we've got negative 4. Negative 1 twice because of the bounce. 4 and 6. So we've got x plus 4, x plus 1 squared, x minus 4, x minus 6. And don't forget the negative out in front. One, two, three. All right. Lowest possible degree 3. We got negative 5. We got 0. And we've got 2. Now the negative 5 is x plus 5. And the positive 2 is x minus 2. What about the 0? Well, that's where you just have x. Oh, we forgot. The right in behavior is up, so that means it's positive leading coefficient. That's a good answer right there. One, two, three, 4, 5, 6. Lowest possible degree 6. Right side is positive. Zeros. Well, we got negative 6 twice. We got 0 twice. We've got 3, and we've got 5. Factored form. Well, x plus 6, but we want it 2 times, so we're going to square it. For the zeros, remember that's x, but we're also going to square it, because x times x is x squared. And then we've got x minus 3 and x minus 5. That was a short set of notes this time, so we're moving on.